So you've already seen the fetch execute cycle. Let's take a look at Little Man Computer and how its simulation of the CPU matches what you've already seen. Over on the left is a window where the assembly language can be typed or pasted in, as in this case. When you press assemble into RAM, the instructions are read and the corresponding values are stored. For example, the instruction LDA value is worked out to be LDA 04, and the reason is that when the instructions are listed one after the other, value, which is 16, ends up being stored in address 4. The instruction LDA has an instruction code of 5, and so the instruction LDA 04 is stored as 504 in memory. So the instruction itself and the data on which it's going to be operating are, if you think about it, stored together in the same location. This is how instructions are stored in real computers too. So this first instruction is loading the value in address 4 into the accumulator. Let's run it and see this happen. First, the value 0 in the program counter is sent through to RAM, and the program counter is incremented to 1. The 504 is transported back to the CPU, where it's split into 5 for the instruction to be decoded and the address of 4. Since the value in 04 needs to be fetched, this is now sent to RAM and the 16 is sent back and stored in the accumulator. Next, instruction time, and the address 1 is now sent to RAM and the program counter gets incremented to 2. The 205 is sent back to the CPU and the instruction 2 is stored along with address 05. This instruction is a subtract, so we have to fetch the value in RAM address 5. The value in that address, 4, is sent back from RAM to the CPU and the subtract is carried out, leaving the accumulator at 12. Finally, the address 02 in the program counter is sent through to RAM, which sends back the instruction 902, which is an output instruction. No extra data being required, the value in the accumulator is sent through to the output. The final instruction is HLT, meaning halt, so the program comes to an end. LMC is a simple model, massively simpler than a real CPU, but it does illustrate what your phone or computer is doing billions of times every second.